Okay, so yes, we already did page 11. Some classes are at different spots on page 11 too. So I want to make sure all my classes are at the same spot. Plus it gives me a chance to review some of the stuff we've been talking about last week. So since Wednesday, we've been talking about energy in the Earth system. So talking about the Earth and the sun kind of as one group. So we talked about external energy last week. What's external energy?
Outside.
Energy from outside the Earth, such as the sun. So we have the sun, which is shooting down energy at us. Does anybody remember what that energy is called from the sun? Oh, well, that's heat energy, yes. But it's energy coming from the sun. It's coming into the Earth. It is right. You're good. Okay, so you're right. You answered the question perfectly, not what I was looking for, but you're right. Whoa, I almost killed you, Cynthia. Yeah, so energy from the sun is coming at us in the form of radiation. And what I'm getting at is I'm talking about incoming solar radiation. You guys remember that? Incoming solar radiation. There's a fancy name for that. Insolation. Insolation's coming at us from the sun. That's our external energy. And do you remember what 3 things will affect how much energy we get from the sun? There's nothing to write now, we're just reviewing. Do you remember that what affects how much energy we get from the sun? There are 3 separate things. What? Time of day. What changes throughout the day, guys? Let's talk about the sun. You're right. Weather changes, the moon changes. Let's talk about the sun. What changes with the sun throughout the day? Huh? Where it is, how high the sun is in the sky. That's called the angle of insolation. Remember that? When the sun's low in the sky, we get a little bit of energy. And when the sun is high in the sky, we get a lot of energy. I actually have to, I want to talk about something that came up as a confusion about this. And I'm not sure if it was this class. I'm thinking it was this class, but it might have been the class before. So let me just say what the student thought. They were talking about when we were closer to the sun and when we're far away from the sun. Was that this class? I feel like it might have been Hayden. Of course, he's not here today. But let me just clear something up. I am not talking about being close to the sun or being far away from the sun. Imagine the sun was on my fingertip. And I put my fingertip out straight. What kind of angle is that? And by the way, I want to live here on my nose. Is that a high angle or a low angle that the sun's making with my nose? It's low. In fact, it's 0. Now, as the sun goes up, now that's a high angle. Now, does my arm get longer or shorter when I move it? No. So how far is the sun away from us in its trip around? Same distance. The sun's always the same distance from my nose. So it's not that the sun's getting closer or farther away. The sun stays the same distance. The only thing that's changing is whether it's hitting me at a low angle or a high angle. So I just wanted to clear that up. We're not getting closer or farther away. So the first thing that changes is the angle. If it's, when are we going to get the most energy from the sun, at a high or low angle? High angle, the more straight up it is. Good. Do you remember another thing that affects how much energy we get from the sun? So like if I wanted to put a solar panel out, the one thing that's going to affect how much energy I get is the angle it hits. What's another thing that's going to affect how much energy I get to that solar panel? Whether or not there's cloudy, no, that's my 3rd one, so I can't push the button yet. You guys know that if it's a cloudier day, we get less energy. If it's a clearer day, we get more energy from the sun. Remember that what now is going to be the 3rd, but it's my 2nd bullet when we went over this. That's okay. So you're getting ahead of yourself. You're talking. She said seasons. The seasons are going to change the angle. The seasons will also change this 2nd bullet that I'm looking for. What's the other thing that changes changes the amount of energy we get? Hey, if you don't remember, it's like we already did this in our notes already. maybe flip back. How about not maybe flip back? Why don't you all flip back until you can find the 3 things that affect how much energy we get from the sun? Nah, not maybe. I got rid of the maybe. I want everybody. No, you're on the wrong page then. This was back on Wednesday. One of the first things we did this chapter. Everybody flip back to the beginning of the packet. Turn one more page. There's where you have internal and external there on page 3. The angle that it hits. Atmosphere. So yeah, the atmosphere is another one. What was the second bullet? No, we're for external energy. I might have said. Yeah, how long the sun is out. Because if the sun's out a long time, won't we get more energy than if it's not out a long time? Yeah. So those are the 3 things. So that's what we learned last week. There are 3 things that affect how much energy we get from the sun. Now what I want to do, which is what you were thinking of a second ago, is I want to talk about each one of these and what changes each one of these. So we're going to start with the angle of insolation, which we did on page 11 already. Sorry. The angle again is how high the sun is in the sky, and it's measured in degrees. We're on the bottom of page 11 here. It's measured in degrees like angles. So if it's a low angle, like straight out 0, straight up is 90. So those are the 2 different ones. If it hits at a high angle, it's gonna be hotter, brighter. Yeah.
So the sun doesn't just come like straight up and straight down, right? It like moves like that.
Yeah.
So does the moon just appear when it's dark, or does it move the same way?
No, so the moon moves the same way. There's a little bit more to it. Because so the moon, I don't know if it's out right now. I would have to check. But the moon might be there. We just can't see it because it's not dark out.
But it moves.
Yeah. The moon, we move just like for this, which is what we're going to learn next chapter. So the moon pretty much stays still, just like the sun pretty much stays still as we turn, but the moon does move too.
So it's the same concept as the sun?
Yes.
Okay.
Pretty much. A little more to it, but pretty much, yes. The reason it rises and sets, the moon, is because we're turning, yes. But the fact that it rises and sets at different times is also because it's the way. And I don't want to get into it yet. So 90 degrees is when the sun's straight up. And by the way, that never happens around here. The sun will never be straight over our head because we're not at the equator. Never goes at the North Pole either. It's only directly overhead near the equator. Low angle, not as much sun, not as bright, not as hot. So there's 3 things that affect. So now we're on to page 12. There are 3 things that affect how much, or 3 things that affect the angle the sun hits. See where it says 1, 2, and 3 as you go down the paper? 1's at the very top. I think we already filled it out, time of day. 2 will be latitude, and then 3 will be season. That was confusing people last period. Figure out what I meant. Thinking I should change that for next year because it's confusing. My tag is itching my back so much, it's making me insane. It's not like one that's, I don't think it's gonna help. Oh, it's making me insane. All right, so we're gonna focus, we already did time of day. And all we did for time of day, again, this was not rocket science for you. Nothing on that we wrote on Friday should have been news to you. Sunrise, the sun's low in the sky, not very bright. If we were collecting energy in the solar panel, we wouldn't be getting much energy at sunrise. Same idea, if you guys were gonna go out to get, like you were going outside, you were gonna get a sunburn or a suntan. How good are you gonna get a suntan at sunrise? Not good, right? How about at sunset? Not good. When is like, I don't know if you want to call it the best or the worst time, but when are you going to get the most sunburn? Okay, so anytime between in the water, we'll get to that too. But anytime around noonish. Now I do want to say it is around solar noon, which is not exactly noon. It's around noon, can be anytime between like 11 and like 1:30-ish. It does get hotter in the afternoon sometimes than noon, and that's again because there's more going on. Like 4 o'clock might be hotter than noon, again because there's a little bit more going on. But if we were talking about sunburn, the easiest time to get a sunburn would be around noon, and then it gets a little less sunburny as the day goes on, even if it's still warmer out. Do you like the word sunburny? No. All right, latitude. Nothing to write again yet. You guys remember what the latitude of the equator is? 0. If you had to look at this map to figure that out, you do. I mean, technically you don't have to remember that, but you should. So here's the equator. It has a latitude of 0. What's the latitude of the North Pole? It's not labeled. 90. You should remember that as well. What about the South Pole? That is also 90. So this is 90 degrees south. I should have labeled that one with the 90 degrees north. So latitude, and here's the Earth is tilted, which we're going to get into next chapter. But due to this tilt, I'm not even going to get, no, I don't want to talk about it. So let's just move on. Sorry. I don't want to talk about it. Here's what I want to talk about. The latitude. The lower the latitude, the higher the angle of insolation, which means the lower the latitude, the higher the sun is in the sky. And if we break that down, and this is all you need to write on all those lines, so you can take up as much space as you need. I'll let you. Mrs. Ritz. Yep. Okay. Yep. Jacob, you're being picked up. So the closer we get to the equator, the higher the sun is in the sky. As you go away from the equator, the sun gets lower in the sky. Sorry, I'm just looking up something. Let me change the date. So today, I can't figure out how to change the day. Today, the highest the sun will get in Buffalo is about 50 degrees in the sky. Is that hot? So we're not talking about temperature, we're talking about how high it is in the sky. So keep in mind, straight out, what's the angle straight out? 0, what's the angle straight up? 90, so what's about halfway? Halfway between 0 and 90? 45. So we're a little bit above that. So the sun doesn't get much higher than right around there today. Is it 70 something on the first day?
Oh, the first day of
Summer.
71.5.
Okay. So it doesn't get ever up here. It's about there. It's about the highest it ever gets in Buffalo. Yeah.
Why do you burn faster in the water? You would think because it's cold.
Yeah, but remember the burning is not, so just because you're cooled off doesn't mean you're not going to get burned. It's the energy that's hitting you from the sun and in the water. So yes, it's probably you're in the summer, first of all.
Yeah.
So it's probably summer. So the sun's probably pretty high.
Uh-huh.
So first, just because you're cool that you're forgetting that you're getting burned. That's the big problem. So even still like on a May day when it's not super hot, but the sun's getting pretty high in the sky, you're forgetting that just because you're cold doesn't mean you're not burning. So that's the first thing.
How do you burn faster?
Well, so the first way is you forgot to put sunscreen on because you're not thinking about it because you're cold. The second way is because it also bounces off the sun and back up at you. Oh yeah, sorry, not the sun, off the water. Thanks, Mr. D. Bounces off the sun too, but yeah. So it's gonna hit the water and just like if you ever seen like they always were like in the 70s, like shows set in the 70s where they put like a mirrored thing around their face to get a sunburn. Have you ever seen that? That's why, because the sun, not only are they getting the sun when it hits them the first time, but they're bouncing off the mirror to hit them in the face.
What's the mirror have to do with water?
The water's have you never been on water on a summer day?
Yeah. I have.
Is it kind of like a mirror?
I don't know.
You never noticed that where it's so bright, like kind of like snow. It's the same idea. So the mirror acts like a lake. It's the same idea. The water is really shiny, reflecting off the sun. But the main reason is because you forgot to put sunscreen on. I'm not kidding. Yes, lots of people, you're just getting burned a lot slower with the sunscreen. So that's what the sunscreen means. That's my understanding is if you would have burned in 0 minutes, the SPF 50 gives you 50 more minutes. That's my understanding of it. So if it's SPF 15, you have 15 extra minutes before you burn. Again, that's my understanding. I could be wrong.
Aren't you supposed to like reapply?
Yeah, the directions say like you're supposed to reapply like every time you sweat, every time you get wet, every couple minutes. Well, you will regret it when you start getting wrinkles and sun damage. Wish I would have worn some more sunscreen. Anyway, moving on. Enough about my insecurities. So if you're close to the equator, the sun's always going to be higher in the sky. Speaking of sunburns, if you've ever gone to Florida or Arizona or Texas, yes, those places are hot, but that's not where I'm getting at. Where I'm going is it's easier to get a sunburn there. You will burn much faster in Florida than you do in New York. Not just because it's hot, but because the sun is higher in the sky. Season is the next reason that the sun changes where it is. So in the northern hemisphere, the sun is highest in the sky on June 21st, which is the first day of summer, by the way. And because the sun is high in the sky, that's one of the reasons we're going to have warmer temperatures. Just like it's warmer at noon than it is in the morning, it's warmer in the summer than it is in the winter, again, because the sun's high in the sky. It's lowest in the sky in December. This is not the only reason it's warm in the summer and the only reason it's cold in the winter, but this is part of it. And the last reason the sun changes position. Well, I must have got off topic when I talked about Florida. Oh, yeah, because we were talking, that's Connor's fault. The other reason the sun appears to change angles is because, oh, no, we already did latitude. Okay, I'm good. So on the first day, if this was us, first day of spring, the sun is right there. The first day of winter, the sun is a lot lower in the sky at noon. And the first day of summer, we have about that 70-degree angle that Mr. D was talking about.
I can watch the YouTube video.
No, this one is awful. We'll watch a different one though. This one is painful. Not even, like, this is science painful, not just boring painful. Because it's talking about like sciencey things that are just a boring person talking, even more than me. But we'll watch another one. But thanks for paying attention there. All right, so now we're gonna move on to duration. Duration of daylight, top of page 13, is the length of time the sun is over the horizon, or in easier words of thinking, it's the amount of daylight. Do we have the same, always have the same amount of daylight? Cynthia says no. How about the rest of you? Do we always have the same amount of daylight? No. Brad, when does the number of daylight hours change? Like, okay, so that's not it. Daylight savings time does not affect how much daylight we have. It doesn't matter. Let's go back to daylight savings time. It doesn't matter if the sun rises at 6 and sets at 5, or if it rises at 7 and sets at 6, it's still the same amount of daylight. Yeah, the seasons. Brad, did you notice what time the sun was up this morning?
Yeah, it was like 6:30.
It was. Is that before or after you got on the bus? Or
before we left.
it was out before you left. I was on my way to work and I noticed the sun was rising. Brad, when you're coming to school in December, is that the sun up then too? No, not at all, in fact. So the seasons will change. I think you guys have noticed that. In the winter, sun doesn't rise until you're already here at school some days. So summer solstice is the longest day of the year. That's the first day of summer. The winter solstice is the shortest day of the year, which is the first day of winter. And the equinoxes are 12 hours and 12 hours of daylight, 12 hours of darkness. So I had, what I decided, because I just asked Brad what time the sun rose, and he's pretty darn close. He said 6:30-ish. It was actually 6:52. It was off by 20 minutes, but that's pretty close. Sun rose today at 6:52 a.m. It will not set until 7:45 tonight. What? Almost 13 hours of daylight, 12 hours and 52 minutes of daylight. Did you guys even notice a difference like last week? When you were coming to school, was it as bright as it was today, or don't you have any idea what it was like last week?
I forgot.
You forgot? Even just the difference between today and yesterday, there was 2 minutes and 53 more minutes of daylight today than there was just yesterday. And then 2 minutes and 54 seconds more than the day before. So it's 5 minutes different just this weekend I should have pulled up what it was last week, but the sun definitely is rising a little bit earlier this week compared to last week, staying darker a little bit later. I wanted to put up Alaska. What do you guys know about Alaska? What? Couple hours. I think, let's see, here's today, their sun rose at 6:55 a.m. Set it. It will set at 8:54 p.m. Does that sound like a couple hours to you?
No, it sounds like 13 hours.
Sounds like almost 14 hours. So I know what you're talking about, but I just wanted to bring this to light. Today, Alaska gets almost an hour more sunlight than we do. Does that blow anybody's mind? Hey, isn't it cold in Alaska? But they're getting more light than us? Does it blow anybody's mind? It does mine at least. Why is it so cold in Alaska? Thinking about what we just learned. Thinking about what we just learned like 4 minutes ago. So hey, 4 minutes ago, we were on the other beach. Just saying. That lets everybody else figure it out now. So guys, Alaska, they're getting more daylight than us. Why is it so cold in Alaska? Think, review from the page before. Anybody else figured out why Alaska is much colder than us? You think you did? Why? Sun doesn't get very high in the sky. So the sun is out for 13 hours, but it does not get very high in the sky. Only gets to 31 degrees in the sky. That's the highest their sun's going to get today. That's about there. Let's watch what this would look like. So Brad wanted to watch a YouTube video. Let's watch this one. I don't love this one because it doesn't give me time of days. Well, and then there's that. They blurred out the bad word. All right, so this is the first day of summer in Alaska. 24 hours is about to be shown here. I wish they would have put a timestamp on this, but they didn't. I'm going to ask you two things. We haven't gotten through a whole day yet. That was night. You just watched night. Here's day. More day. More day. Here's more day. Still the same 24 hours. I do wish there was a timestamp. All right, starting to get a little darker. Notice, here comes sunset. What do you notice during sunset? Sun already set. This is night. Still daytime. Oh, day again. First of all, it didn't really get dark. They have short amounts of light, or they have short amount of night, sorry. You were right with the way you said it. They have short amount of night in the summer. Let's see what it looks like in winter there. Struggling with PowerPoint here today. Here's the first day of winter in Alaska. This one's better because it shows, oh, I did mess it up. I am not good at this. Sorry, we didn't miss anything. So it's night, sunrise, first day of winter, 10:58 a.m. Guys, that's fifth period. Here's sunrise. Here's day. What's one thing you notice about their day? Still basically night, still pretty dark. Where's the sun? Right at the edge, right. Let's see how high it gets. We got some cute music with this one. It is. I don't know why they just have random music. It's almost noon. 12:52. Look how high the sun is. Look at the light. What do you see? Still basically dark. It's sun's barely over the horizon. And that was at 12:52. It looked like this. Sun's starting to go down. It's already getting lower in the sky. Cool music again. I don't understand. It's the opposite of summer. Now, okay, here's sunset. Right now. Nope. So sun rose during fifth period, and there it's the sun set at 2:47 p.m. Sun was out for 4-ish hours. And did you see what it looked like when it was out? Still really dark. Looked just like maybe around 6 o'clock for us in the morning. So the sun stays low in the sky. It didn't matter if it was summer or winter, the sun was super low in the sky. And it was out quite a while during the summer and barely out during the winter. And I have those exact numbers. These numbers you obviously don't need to memorize or know anything about. I thought it was interesting. So again, this is for us. This is in April. For us today, we're getting 12 hours and 52 minutes of daylight. They're getting 13 hours and 58 minutes of daylight. Here's what it's going to be like in June, the first day of summer. For our first day of summer, we have 15 hours of daylight. Sun rises at 5:37, sets at 8:57. So almost 9 o'clock at night, it's still going to be light out. It's going to give us a little more than 15 hours of daylight. Let's look at Alaska. Sun rises at 2:58 a.m. Sets 12:47 a.m. That's 21 hours and 49 minutes. That's almost 23 hours or 22 hours of daylight for them on the first day of winter. Summer, first day of summer. Sun's out real long. But if we look at the angle, this is the angle of solar noon. The highest on the first day of summer the sun will ever be is 48 degrees in the sky. So it's no higher than it is for us today. So it's pretty low. Want to see what the first day of winter? For us, our first day of winter, sun rises 7:43, so a little after school starts, sets at 4:44. That's 9 hours and 1 minute of daylight. In Fairbanks, Alaska, sun rises at 10:58, sets at 2:40. That's 3 hours and 41 minutes of daylight. And you saw what their daylight looked like. It was our twilight. Cool, huh? How'd you feel about that? You'd like it? Oh, lame. I thought you said it seems tolerant, which I didn't think was your words. Yeah, it does seem lame. How do you do sleep if it's 24 hours of daylight, basically? How well would you sleep, you think? Is it hard to go to bed on those summer days when it's so nice out? Imagine what it's like for them. It's light out until 12:47. Curtains, all right. So let's do the opposite. It does get darker curtains. They make them too. And I'm sure they have them. At least most people probably have them. Let's talk about the darkness. Isn't it in the middle of winter when the sun's setting around 4:30 in the afternoon? Don't you feel a little blah? Imagine if the sun set at 2:40. And it didn't come back up again until almost 11 o'clock. That would stink, I would think. Moving on, if you're not as intrigued as I am. So for duration, did we write this part? Length? Okay, so then we got latitude. Depends on latitude and time of year. Page 13. So by time of year, I mean different seasons. And then what do we need about that? At the equator, 12 hours of daylight all year long. So places at the equator, sun rises at 6:30, sets at 6:30. And this is it. Okay. Michael, they need you in guide. So, yeah, oh yeah, periods just about over. So at the equator, sun rises around 6 in the morning, sets at 6 at night. So you know those baseball games you play and the lights don't turn on until like the 8 o'clock game if you have a late one? You don't play baseball? Sorry, but I guess you can't relate. Yeah, they don't, in the summer, those lights probably don't turn on until around 8 o'clock at night. If you lived at the equator, those lights would turn on at 6:30, maybe 6 o'clock. They have no long summer days. So I guess it's easier to go to bed earlier for them, but they have none of those nice summer night days. Still hot, but they don't have the nice long days. All right, as latitude increases in the summer, we're going to have longer days, which will give us warmer temperatures. The sun's out longer, it gives the earth it's easier for the earth to warm up. In the winters, you have shorter days, and this is nothing you have to write here. I just wanted, those were those YouTube videos we watched. So summer days are warmer, winter are shorter and cooler. And the last thing I want to do is on page 14. I do want you to try and get all of this in. If you can't, this is where we'll start tomorrow. But we talked about if the clouds are out, we'll get less energy from the sun. So here's what happens to energy coming from the sun. The numbers are not important. You do not have to memorize the numbers. I just want you to realize what could happen to all that incoming solar radiation. So go ahead and write it, and this looks like where we'll start. And you do have homework. It was on page 13. There were 3 questions. So if you can get this in, and then the homework is on page 13, then we are done for the day.